How the hell does this Gradle stuff work? Hi, Marco here. By the end of this video, you're going to have learned the 90% of Gradle knowledge that allow you to build literally any Gradle project out there, be it open source or be it any of the projects that your corporate job throws at you on a daily basis. For the remaining 10%, I'm going to sell you a course. Isn't that cool? No, I'm just kidding. You're going to get all the juicy information for free, but only if you subscribe to this channel. All right, let's start. All right, so imagine it's your first day of work at a new job. Your colleagues tell you, well, they have a flagship product and it's a Gradle project. Who would have thought? Now, the next step for you is to obviously clone their project and see if anything is working at all. You'll find the flagship project for this video down below. So I'm just going to clone it. And as I don't know much about Gradle yet, I'm just going to go into the Gradle tutorial directory I just cloned, and I'm going to have a look around. Now, there's a couple of directories and files inside here, but let's forget about that for a second. My colleagues told me just try and enter Gradle W build without knowing anything else about Gradle. And as I can see, actually there seems to be something happening. That was rather fast, but I saw something about compiling Java source codes, about some tests, and then the build was successful in 3 seconds. The question is, why is the build successful and what just happened? And we're now going to find out. Now, first of all, what was that command Gradle W? As you can see, early on, there's two files, Gradle W, Gradle W.bat. Gradle W stands for Gradle Wrapper, and it's an embedded version of Gradle. So which means you don't have to have Gradle installed on your machine. Instead, literally any project out there, any Gradle project out there, comes with its own Gradle version called Gradle Wrapper. Gradle W is the command you execute on Windows. Gradle W without the .bat is the command you execute on Linux and Mac OS. Then there's a Gradle directory. I'm just going to go step inside that Gradle directory. And yes, there's another subdirectory, the wrapper. And this is my actual Gradle Wrapper jar file. So you can ignore that Gradle directory for now. Later on, we're going to put some other stuff inside here. But for now, just housekeeping. These are all related to the Gradle Wrapper at the moment. Then there's a settings.gradle file. Actually, there's just one settings.gradle file at the root of every Gradle project. It's a great indicator that apart from the wrapper, it is indeed a Gradle project. And what we can do is, I'm just going to type settings.gradle on Windows. Please, on Mac OS Linux, if you follow along, just do a cat settings.gradle. And as you can see, there's just 3 lines inside that file. First of all, we specify the root project name, which is called my multi-module app, which doesn't make sense since it's a flagship product. But anyway, you can see 2 lines here, include my backend, include my web app. What's the thing with these 2 lines? Now, I first thought, let's have a very simple Gradle example project. But then I thought, no, let's forget that. Let's have a real life multi-module project. Because our flagship product is a web app. So there's a my web app folder where you have maybe some JavaScript and some HTML templates, whatever. And there's a different module, my backend, which might have some SQL database related stuff in there, whatever. We split the project across 2 modules. We could have more modules. We could have just one big module. In any case, I chose to go with 2 modules for this video. And in the settings Gradle file at the top, you tell Gradle, well, I have 2 modules. They're my backend referencing the folder, also my web app referencing the folder, and that's it. And then when you enter a command like Gradle W build, what actually happens is that Gradle has a look inside that settings Gradle file, checks out, hey, I have 2 modules. I need to figure out which one I have to build first, or if I can build them in parallel, whatever. And then it just goes along. My backend builds it, compiles your Java source code, runs some tests. Same for my web app. And at the end, you hopefully get something out of it, which you can deploy inside the cloud or Kubernetes, microservices, whatever. We're going to have a look at that, what comes out of the build process in a second. And for that, we need to understand the general Gradle project structure. All right, so I'm going to step inside the My Web App folder. And as you can see, there's a build subfolder, a source subfolder, also a Build.Gradle file. We're going to spend most of our time in just a couple of minutes dissecting what goes into a Build.Gradle file. For now, I just want to focus on a source folder because Gradle essentially shares the same project structure convention as Maven does. So all your Java sources and all your Kotlin sources, for example, whatever have you, they go into source main, and in the case of Java, source main Java. There you'll find your package like com, Marco, and then your Java classes. You also have source main resources. Inside source main resources, you will find stuff like your application properties files, SQL files, and whatever have you. Now, as we're reliable developers, there's also source test. And you might have thought that, well, right, correct. All your test classes go inside source test Java. And if you had test resources specifically, then they will go into source test resources. Now, what actually happens is when you run Gradle build, the Gradle goes through source main Java in my case, compiles all these classes, then goes to source test Java, compiles all those classes and runs those tests. And at the end, well, running tests, creates test reports, for example. And then building the whole project should, build a final executable I can put somewhere. It's a web application, right? And to find all that stuff, you need to go inside the build subfolder, right? When you have a look at the build subfolder, you'll see that here there's a classes subfolder having all your compiled Java classes. You will have reports, test results, right? HTML reports, actually, we're going to have a look at them later. And you'll have, most importantly, a libs directory. And this is by default where your final executable, so to speak, gets put. So inside here, I run Gradle build. I know my web app is going to have a build lib subfolder. Inside here, I have a jar file. Now, if you know how Spring Boot works, you'll know you can run that jar file just by going java jar my web app, right? Like so. Or rather, you make sure you take the correct path. You run the application, open up a browser, go to localhost 8080, and you see a hello world application. Wow, it was totally worth it to build that application. But in any case, well, you should keep in mind that whenever you build a Gradle project, build libs is where the juicy artifacts live. All right, I'm back in my project's root folder. Let's execute a couple more popular Gradle commands, like, for example, Gradlew Clean. Now, what does clean do? Well, let's step back inside my web app folder, and you can see the build folder is gone. That's right, because clean deletes build folders. Then there's also Gradlew Test, which you might have guessed correctly, 100 points for you, that Gradle will go through the submodules, source test Java, find those files, and execute them and run them and generate reports actually also for those tests. And if you want to, what you can do is now go back inside your My Web App and enter long directory /build reports test. Inside here, you'll find an index.html file, which I'm going to open up with Explorer, good old Explorer here, because I'm on Windows, which pops up the window, and you'll see a nice test report here. As an HTML file, there was one grand test which was run. 100% successful, right? No failures, duration, whatever. Really cool to have these test reports, and obviously these test reports also later on can be directly integrated into IntelliJ or your build tools like Jenkins, TeamCity, and whatnot. We'll talk about that in a second. But for now, there's one last thing I want you to take away. Let's step back into our root directory again. And the question is, do I always have to build all my submodules? Do I always have to test all my submodules? No, you can also choose to just test a specific one. You would write Gradlew Test -p, for example, for the submodule, and then you reference the directory path. So my web app in that case, right? You run that, and then you can see that only actually my web app module was tested. And also there's a tiny little hack what just happened. Gradle was smart enough to understand, well, since the last test run, what you didn't do is you didn't create any new classes, you didn't create any new tests, whatever. So in fact, there weren't any tests run this time because the test results were still cached. And that's also the magic, let's say, of Gradle, that it tries to be smart and tries to understand, hey, what do I really need to run? What do I really need to build? How can I save you time when building? All right, enough babbling on the command line. Let's fire up an IDE. Okay, I just fired up IntelliJ, the community edition, which is free, and it has great Gradle support. So what I'm going to do is I'm just going to go to my directory, right? And just going to open up the directory. I'm going to trust this project because I know it. And then what you'll see is it's going to take a while, but essentially IntelliJ runs the Gradle import process. All right, once that's done, let's see what IntelliJ can do for us. Well, first things first, you have some highlighting. Obviously, you can now see that visually there's two submodules, my web app, my backend. But now it's time to step inside a Build.Gradle file for the first time in this video. That's where the magic happens. That's where you configure your submodules or your Gradle project. Now I'm going to run you through all these different blocks, but for now we're going to start with the most important one, the dependency section. By the way, the language being used inside these files is Groovy. You could also write these Gradle files with Kotlin, then they would be called build.gradle.kts, but I wanted to show you the Groovy way because there's a ton of Groovy projects out there, Groovy Gradle projects to add to the confusion, even though if you're starting a new Gradle project, I would advise you to go with Kotlin, but more on that in a bit. Now the dependency section, what you can see here is Gradle can obviously pull in third-party dependencies for you. And every project nowadays needs third-party dependencies. Here we're getting 4 dependencies, the Spring Boot Starter Actuator dependency, whatever, Starter Web, yeah, okay. We seem to have a dependency on the project, my backend. That's the syntax, how you reference other projects with a colon here. And another dependency, Spring Boot Starter Test. Now it says implementation here and test implementation. What does that mean? Well, it's dependency scopes. And if you're coming from Maven, for example, you know that dependencies can have different scopes. For example, in Maven, they can have a compile scope and they can have a test compile scope. To answer the confusion, you could also in the past use compile, test, compile with Gradle, and hence you'll find tons of projects, instead of having written implementation here, having compile here, for example, with older Gradle versions. But at one point, the Gradle developers changed compile to implementation, test compile to test implementation. What does compile mean or implementation mean? Well, it means dependency will be available during compilation of the project, right? And during runtime. Test compile, the same thing when you compile your tests on the test class path, so to speak. There's one other popular scope, which is called API. And I'm going to show you what API means in a second. But for that, what we're going to do is we're going to go to my backend's Build.Gradle file, look at the dependency section, ignore everything else up here, just dependencies like you would do in a real life project. And we're going to add our first dependency to the Build.Gradle file. All right, let's imagine we want to add the popular Google Guava library to our project. And you could go to Guava's GitHub page, scroll down a bit, and as is the case with most projects on GitHub, you'll somewhere find, the dependency line here, the Gradle dependency line. So you could just copy and paste that inside your Build.Gradle file. Or if you're already a bit more advanced, you could use a package search machine, just like JetBrains package search, where you simply enter Guava here, right-click Guava. Then you can see that, well, there's a couple of different ways, Gradle Groovy, Gradle Kotlin, Maven dependency block, SBT dependency block. And you can just go with the short version here, the Groovy version, copy that, and you're also good to go. Depends on you how comfortable you are. Right, then let's step and go back to our Build.Gradle file, paste in the Guava line. What you'll need to do now is actually click this refresh button here in the upper right corner, load Gradle changes. Otherwise, IntelliJ won't reload your Gradle script, reevaluate it, right? And then you won't find the dependency. But now, after doing that, and when I go open up my external library section, you should see, yay, here is Guava, everything works as expected. Now, I could have the idea to say that, well, my web app project has a dependency on my backend. My backend has a dependency on Guava, which means, transitively speaking, can my web app module now use Guava itself? Well, let's try it out. Let's open up the test class here, and let's use a class that comes with Guava, like immutable set, for example. Let's just create a new immutable set. So immutable set of 1, 2, 3 doesn't need to make much sense. When you compile this, however, this line now, what you'll find is that I get an error message saying, well, the package Google Common Collect does not exist. Why is that? Well, that has to do with scopes. Now, if you have a dependency set to scope implementation, it means your module can use the dependency, right? And you can compile your module, but it's not part of the public API, which is such a convoluted way of saying now, even though my web app includes my backend, it will not see the Guava dependency, right? If you wanted to change that, and by the way, the clean way is to just tell the my web app module to use Guava. But if you wanted to change that, you would change the scope to API. There comes another problem. The API scope, if I just try and reload my project now, I'll get a new error message. And this is, part of, playing with Gradle, that sometimes you just see error messages. It somewhere here says that it doesn't actually know what API means. Yeah, right. Could not find method API for arguments for the dependencies block here. And this is because, that brings us to the next section, plugins. Everything in Gradle is essentially a plugin, meaning that by default, Gradle scripts can't do much by themselves. You have to tell them, hey, please apply a plugin, which you can do, for example, by saying ID Java. There's a couple of popular core plugins like the Java plugin. You just go there and say, hey, I want to apply the Java plugin to my project. The Java plugin's job is, what we talked about early on. Source main Java, source test Java, run, all the Java classes and whatnot. The problem is the Java plugin here does not understand the API scope. For that, you need another plugin, which is the Java library plugin. Now, the Java plugin, to add to all of that confusion, was in the past the main plugin you would apply to Java projects. But again, this changed. So if you want to have the API scope here, you'll actually need to change it to plugin Java library. It's a bit confusing, isn't it? I just reloaded the project. Actually, let me try and recompile it now to see if it actually works. When I open up the build task, everything was successful. So now I can actually use the Guava dependency transitively. Again, make sure to specify your dependencies wherever you need them. But I just want to tell you, if you're coming from an older project where you have still compile and test compile running and you want to upgrade to newer Gradle versions, you'll need to change compile to implementation/API or to test implementation. Wow, that was confusing. So let's finish off with something simple. We had a look at the dependencies block. The question is, where do the dependencies come from? They come from repositories. Hence, you configure your repositories saying that please use the Maven Central repository to download dependencies, or use my Maven local repository to download dependencies. Use a Google repository, for example. A set of different repositories. You can find out more about them in the Gradle documentation. Then we can configure Gradle specific tasks, like for example, the test task that we ran early on, and telling Gradle, please use JUnit to run these tests because, well, these are JUnit tests. So you need to use the JUnit platform. You could also use the test in G platform. If you use the test in GTest library, different platforms and whatever. Then we have other stuff like, for example, the group version source compatibility, where it seems like you can specify, well, this project needs Java 1.8. It uses a specific group and a specific version. The interesting thing about it is, and that goes back to the dance we just had with the plugins. One of the main problems with Gradle is there's 20 million different ways to achieve the same thing, especially because there's historically have been multiple different ways. You'll still find them online on Stack Overflow. People just copy and paste the stuff. And this way of specifying your source compatibility, the Java version, the group and version ID, is not up to date anymore. I'll actually show you in a follow-up video many things to clean up these Build.Gradle scripts with the most modern way, even though you will see those lines used in projects, especially in corporate projects, because no one, always updates Gradle to the latest and greatest format, so to speak. Which brings us to the very last topic for today. Creating a completely brand new Gradle project from scratch without cloning it from somewhere already with the Maven wrapper enabled. The way to do that, unfortunately, is you need to install Gradle on your machine. And obviously, I want you to use your package manager. For example, on Mac OS, you would just go brew install Gradle, for example. On Ubuntu, apt-get install Gradle. On Windows, the way I did it with Chocolatey Choco install Gradle. And then you can go to any directory on your machine and just, call the Gradle command. Now I'm just going to I'm going to create a new subfolder, my Gradle project. And inside, I'm just going to run Gradle Init. Gradle Init is basically a project wizard. And what you want to do is you have multiple options, and you can read about the Gradle wizard on the website, on the documentation. But what you want to do is, most likely you want to go with number 2, application. That is an application where you can have multiple submodules like we did in this video. Then it prompts you to say, well, do you want to use C++, Groovy, Java, Kotlin, whatever have you? And surprise, surprise, that is going to apply different plugins to your project. So we're just going to go with Java. Split functionality across multiple subprojects. Yes, do we want to have multiple subprojects? Yes, we do. We want to have an application. We want to have a library at the beginning, so just 2 sub-modules like exactly in this video. And do you want to go with Groovy or with Kotlin? Actually, I would advise you to go with Kotlin, even though a gazillion projects out there in the wild, and especially your workplace, might well be in Groovy. I'm going to make a different video about the Kotlin DSL in the near future. So for now, just go with Groovy so you can actually repeat everything we did in this video. It's going to take a tiny second. Nope. Generate build using new APIs and behavior. Yes, we want the new APIs and behaviors. What is my project name? My Gradle project. What should be the source package where my Java source code lives? Also my Gradle project. And now the project is there. And now, surprise, surprise, you can do the very same thing that we did at the beginning. You can have a look at, there's your Gradle folder, the Gradle wbat folder. There's your app module. There's your utilities list module. Is that really different modules? I don't know. Let's try and find out by having a look at your settings.gradle file as a start. Include app list utilities. You can see a different way of specifying multiple modules. And what I want you to do now is all the knowledge from what you just learned, what I just showed you, go through these modules and see if you can make sense of the dependency section, the repository section, everything you saw me do, and then come back here. See the link for the next video. We're going to talk about all the advanced Gradle concepts like writing your own tasks, for example, cleaning up the mess across multi-module projects, how to apply different plugins automatically across your whole fleet of submodules, many more topics. But for today, this is all I wanted to show you. Thanks for listening. Don't forget to subscribe and see you next time. Sayonara.